Hi, welcome back to Missing Chemistry. This is Nuclear Chemistry Uranium Decay Series 1. You know, when we were growing up, we were always told, hey, uranium turns into lead through its half-life. And it does. But what they didn't tell us was that it goes through a bunch of different elements to get there. And we basically have two different types of decay in this process. We have alpha decay, which is symbolized by that A there. And so alpha decay emissions is a 4He nucleus or 4,2 alpha, which is called an alpha particle, is removed from the parent atom to change the element to a different element using this equation here. And if we had time, we could actually write out each individual equation, but the video would be very, very long. All right, if you see this funny looking B here, that's beta decay. Beta decay, which is a 0-1e or 0-1 beta, a neutron is converted into a proton, changing the element into another element and releasing a beta particle using this particular formula. All right, so let's take our direct path from uranium-238 to lead-206, and let's see how that process works. So uranium-238 is going to undergo alpha radiation or alpha decay. And it's going to be converted into thorium-234. Thorium-234 is undergoing beta decay. It's going to gain a proton, and it's going to become protactinium-234. Okay, protactinium undergoes beta decay again and turns back into uranium. But the uranium it turns back into is not the same uranium that we started with. We start with uranium-238 right here, and now we're at uranium-234. So we obviously have a change in the number of neutrons. Okay? So let's go back and let's continue the process and see where we go from there. So uranium-234 undergoes alpha decay and loses 2 protons and becomes thorium. So thorium undergoes alpha decay and also loses 2 protons to become radium. Radium undergoes alpha decay and loses 2 protons to become radon. Radon also undergoes alpha decay and becomes polonium-218. Polonium-218 undergoes alpha decay and becomes lead-214. Hey, look at this. Our lead started off, well, we went from uranium-238, right? And now we're down to lead-214. So our lead started off as 214. So let's see where it goes from there, okay? Now, lead-214 is slightly radioactive, so it's going to undergo beta decay, gain a proton by changing one of its neutrons. Notice the atomic mass does not change, just the identity of one of the neutrons becomes a proton. It becomes the element bismuth. Bismuth undergoes beta decay. All right, again, notice that the atomic mass does not change. It's 214, 214, 214, but it becomes polonium, which is element number 84. Polonium, however, undergoes alpha decay. It becomes lead-210. Now, lead-210 is definitely different than lead-214 in one respect. Lead-210 is probably a little bit less radioactive, and it has an atomic mass difference of 4. Okay? Now, let's look at this next thing here. So now we have lead-210, but we're not there yet because, like we said, lead-210 is slightly radioactive, right? So lead-210 undergoes alpha decay. It becomes Mercury-206. Mercury-206 changes one of its neutrons into a proton. It becomes thallium, right? You're going from element 80 to 81, so it becomes thallium. Thallium undergoes beta decay again and turns into lead-206. And that's the end game. We don't go any further because lead-206 It's stable and is not radioactive in any way, shape, or form. Now let's look at the half-life versus the element. Uranium-238 has a half-life of 4.4 times 10 to the 9th years. Thorium-234 has a half-life of 24.1 days. Protactinium-234 has a half-life of 1.17 minutes. Uranium-234 has a half-life of 2.46 times 10 to the 5th years. Thorium-230 has a half-life of 7.54 times 10 to the 4th years. Radium-226 has a half-life of 1,602 years. Radon-222 has a half-life of 3.82 days. Polonium-218 has a half-life of 3.1 minutes. Lead-214 has a half-life of 26.8 minutes. Bismuth-214 has a half-life of 19.9 minutes. Polonium-214 has a half-life of 1.64 times 10 to the -4th seconds. Lead-210 has a half-life of 22.2 years. Mercury-206 has a half-life of 8.32 minutes. Thallium-206 has a half-life of 4.2 minutes. And Lead-206 is stable in-game, which means it's not radioactive at all. You guys be snarly, and we'll see you back here at Musin Chemistry.